Alright, so this is going to be your introduction to the Adafruit Circuit Playground Express, which is this board right here. It is a super neat little board. It's got a ton of stuff on it, and the reason I like to use it is because you get to program it, but you also get to see how hardware works in the real world. So you get to play with lights and sensors and all of that good stuff, but you don't have to do any kind of wiring or anything like that for it. So there's a bunch of things to notice on here. The first is this ring of like little square things with circles in them. There's 10 of them. So those are RGB LEDs. So red, green, blue LEDs. LED is light emitting diode. But essentially they are rainbow lights. And that is a lot of fun to play with. There are also these clicky buttons. There's one here, your B button, and that's our A button. They're labeled. There's labels all over the board, so definitely look for those if you get confused. And then there's also this reset button in the middle. Don't get too crazy with that because that is, you can reset like the whole board in ways that you don't want to, so for the most part just try to ignore that. There's a little teeny slide switch right up here, and you can slide it back and forth. It's a little sticky, but it does go. And then in addition to all of that stuff, there are a bunch of sensors that are kind of smaller. So you can look for the little identifiers around the edges. So for example, this is a thermometer, and it's a temperature setting. I always say we like to make things obvious in computer science. So, you know, thermometer, temperature sensor, tells how hot it is. Here we have an ear, which is going to be a sound sensor. So it's listening like an ear does. Let's see, right here we have a music note, and that, you know, plays music. So we do have a speaker on here. We're not going to be using it in this class because the sound of 10 of these all making random noises is just not a way that I like to spend my day. We have right here this little eye. That is a light sensor. It sees things. It's not like telling you in color or anything like that, but it can tell how bright or how dark it is. And then we also have in the middle right here, we have X, Y, and Z. So that's actually our accelerometer. So it can tell the direction that this board is accelerating in. And we'll talk a little bit more about that later on, but it can tell you in the X, Y, and Z direction how the board is moving. So right here, this is a port where we can plug in a separate battery pack, and here we have where we plug in our board to our computer. It also has this ring of gold things around the edges. Anything with an A, A0, A1, A2, A3, those are all capacitive touch sensors, which works similar to how your phone works. So there's resistive touch sensors, which are the really terrible touch screens that you hate and that never really work right. And then there is also the capacitive touch screen, which is something like what is on a modern phone, where it just kind of works pretty seamlessly. So these are capacitive touch, which means they work really well, and basically if you touch these gold things, it will register that touch if you've asked it to do that in your code. So it's a pretty cool little device. You can also attach motors even and additional sensors to these pads, and then do whatever you want with those. So, like I said, there's a bunch of stuff on here. I actually have a couple that also have Bluetooth on them. I believe there's IR sensors, so infrared sensors. So, you know, look around at it, and you can also feel free to look up more about what exactly this board can do. But for now, we're going to start talking about how to program this. So the first thing that you need to do to program this is you need to open a program called Mu. It is MU. And you can, if you're using one of my computers, it's already on there, or you can go and download it. That is completely up to you. But once you do that, then you're going to open up File Explorer. So here in File Explorer, you're going to find the thing, oh, sorry, I messed that up. So what you're going to do is go to Mu, and then you're going to load your file from here, okay? If you try to just go straight to the File Explorer and open it up, it's going to try to open this file up using the wrong thing and is not going to come up the way you want it to. So you need to use this load button here in order to, oh, there we go. sorry, still getting used to this. Where is, oh, there it is. Okay, so you hit the load button here, and you are going to find your circuit playground code file. So if we look at our file explorer, I'll show you where it is kept. So all of the files are saved on this board, so you never have to worry about having the same computer, but you do need to make sure you know which circuit playground board you have. So if we go down here, you see I have this CircuitPy D drive. That is where my files are going to be. Now on here I have a couple different code files. The one you always are going to want to open is the code file. If there's not a code file, you can make a new one, name it code, and save it to this location. I have other files here. They will not run. The only file that's going to run is this one, the code.py file. So that is the one that you should open. Now I already have that open on mine, so we're going to go back and take a look at that. So you can see code.py, we're all good here. I have a file loaded in here already. You probably have a file in here as well, and it was almost certainly written by somebody else. If you are taking this board, please make sure that you're taking one of the boards that does not have somebody's active work on it. Ask me if you're not sure where to find those. And what we're going to do next is put in a starter file. So basically this is a file that I start everybody with. It just makes it a little bit easier for you to get started because I've done a lot of the basics for you, and I also have instructions written in the comments. So in order to find that file, what you're going to do is go to this link, so bit.ly/2v47x capital E2. I'll throw that in the description as well. Once you go to this link, then you should get something like this. It's called the Bouncing Rainbow Light Starter because that was originally what I used it for. Once you get here, you can hit Control A and then Control C. That'll copy everything in here. And then we're going to go back to Moo and take out everything that was in there, so you can just delete it all. This is why we need to be really sure that this is code that is going to be yours, that someone else is not working on, because you are deleting all of their code. Then we Control V, and we should be able to paste in our starter file that we just got. Now, if you press the Save button, if your Circuit Playground was lighting up, it should stop, because this bit of starter code isn't actually telling your board to do anything. Let's walk through what this piece of code is telling your board to do. So right here, anything starting with a hashtag, that is a comment, which means the computer ignores it. It is for people. So for example, this tells you that this file was originally made for an 8th grade tech core class at the Wheeler School in spring 2019 by me. In here, you can say modified by, and then put your name. That way, if you ever have a question of whether or not this is your board or not, you can open up the file, and if you see your name, it's your file. It tells you that it is a starter file, and again, the computer is ignoring all of this. This is for humans to read. Once we get down here, we start seeing actual code popping up, and now these lines of comments are telling us about that code. So for example, we are starting off by importing the necessary libraries. Now libraries are code that other people have written that makes it easier for us to write our code. It says it all in the comment. The libraries we are importing are time, board, and this CPX library, which is part of the Adafruit Circuit Playground Express kind of group. So just know that that is code that other people have written for us, and I'll kind of let you know when we're using those libraries, and it also should be fairly obvious. Now here, this is called a block comment. Basically, if you do 3 single quotes and 3 single quotes, everything in between them is going to be ignored by the computer. So this is instructions on how to actually set a light, which is called a pixel on this board, to turn on and off. So basically we use a number 0 to 9 to select the pixels. The 3 numbers in the parentheses are RGB values, so red, green, blue, from 0 to 255. And you can use a Google color picker to find RGB color values that are specific for what you want. There's some examples right here. I'm going to talk you through, and we're going to do this all together. So remember, this is here, so you can look back at it if you get confused, but don't worry too much about it for right now. Now RGB values are a little weird, especially if you've never done them before, so I went ahead and made some color variables. So basically, if I want something to be red, I can just type red. If I want something to be pink, I can just type pink. If you want it to be orange, which is not listed here, then you have to make your own RGB value or find your own RGB value for it. So this is just a little bit of a shortcut to kind of get you started with a couple of colors. Here we are setting the pixel brightness to 0.1. There is no reason that you need to set it higher than that unless you have a specific project where that matters, so leave it there for now. If you have a reason to set it higher, come talk to me. But the biggest issue with setting them really bright is that it actually makes it hard to code because it kind of blinds you, and then you try to look back at your screen and you can't see anything. Okay, so hopefully you understand what all of this code is for. If you don't, take a break, come ask me. But let's talk about how to actually code our first light to turn on. And we're starting with that just because it's nice and simple and easy. So in programming, everything runs in order. It runs first line to last line. So it's going to do all this stuff that we've just talked about. It's going to set up all of these things. And then here we get to ask it to do something else, to turn on a light. So we are going to do that by following the instructions that are in this block comment by typing cpx.pixels. So that tells it, hey, CPX library, remember we imported that, we want to turn on a pixel, and then you tell it which pixel you want. I'm going to turn on pixel 0, and I am going to make it red. If I save this, what I should see is that that red pixel turns on for just a brief moment. So I'm going to show you what that looks like on my board. Let's see, where is it? So we'll turn that on, turn that off. So right here, right as I press save, I should see a light blink. And actually, I think it's too fast for the camera to even catch it. Oh, nope, yeah, I see it. So it just flashes on and off really briefly. Now, the reason that it does that is because our code runs through, it gets to here, and then as soon as it gets to here, it immediately stops running because there's no more code to run. So there's no reason for it to stay on. So what we can do if we want that light to stay on longer is we can use something called time.sleep. Remember, we imported that time library. So we go time.sleep. And then in here we say how long we want our time to sleep. So I'm going to have it sleep for 1 second. This is measured in seconds. So again, I can press save, and then if I go back over to my board, you can see that right after I press save, that light will turn on for 1 second and then turn off. So congratulations, you made this do something. So the next thing that we are going to do is kind of play with this a little, get multiple lights to turn on. So pause for a second, see if you can figure out how to make multiple lights turn on at the same time. Now if you're back, I'm assuming you've tried this, but if I want to make two lights turn on at the same time, what I do is I can do cpx.pixels, and I can turn on light 1 along with light 0 by putting them both before that first time.sleep. Because the code, it runs line 41, turns on the red light, then it turns on the blue light on line 42, but that happens so fast that we don't notice it as humans, because this is running really fast, and then it waits for a second. So all we see is that that red light and the blue light come on and stay on together for 1 second. Now if you're trying to do something a little bit different and trying to make them one turn on after the other one, what we can do is we can move this pixel number 1 down below our time.sleep. And then that means we also need to add another time.sleep, and I'll make that one for another second. So if I save this, what I should see happen is one light turns on, and then the second one turns on after a second, and then they both turn off. Now you might be asking, okay, well, but I want that red light to turn off. I just want it to be red light, and then take a break, and then have the blue light turn on by itself. What we do if we want to do that is we have to turn that light off. So you'll notice I have a color called off right here on line 35. So you can actually do cpx.pixels, and you want to take 0, the one we just turned on, and turn it off. So now we should see our red light turn on. Wait 1 second. And then we turn off that red light and on the blue light. So let's go back over and see what that looks like. So red light turns on, blue light turns off, or on, and then they both turn off. So hopefully that gives you an idea of how this works. Now, some things you might run into that are issues. First thing that you should know, anytime you have an issue, is you want to look at the serial monitors. So that is right here. If I click on this, this little extra thing pops up, and if I press save, then it's going to tell me some stuff. So right now it tells me, okay, yep, I'm sending some files over USB, and Control D to reload. Don't worry about that stuff. If you have made a mistake, if your code's not running, if you're pressing save and nothing is happening on your board, what will happen is in here it'll say something. So right now it says line 43 invalid syntax. So it notices that I'm missing that square bracket, and you use this to help you figure out what is wrong so you can debug your code. So make sure that you're looking at this. It will help you out. If you constantly are asking, like, what is wrong with my code, and you don't have your serial monitor up, it means you're not doing quite enough to try to figure out what is happening on your own. So make sure you're looking at this. Even if you don't know what the word syntax means, you can look at line 43 and try to figure out what it is. One thing that I do a lot is I'll misspell pixels, and it'll tell you express object has no attribute pixels, because pixels, P-I-X-L-E-S, is not a thing that it knows, but pixels, ELS, is something that it knows. So watch for your spelling mistakes and have another friend look over your shoulder if you can't figure out what is wrong with a given line. Let me see if this does. Yeah, so you can see it kind of fills in. So if I start typing CPX, it fills it in for me. And then if I do dot, then it comes up again, and if I hit tab, it will complete. So that's especially useful for folks who have trouble with spelling. Alright, so take a minute, play with those things, get some lights turning on and off. If you're back, then let's look at how we fill pixels. So that's this line, line 24, and it works a little bit differently. It is turning all of our pixels on, or all of our pixels off, or whatever color we want. So we go CPX dot pixels. Let me see. I have to use my references sometimes. Yeah, pixels dot fill, and then we put a color name in here. So actually, no, I'm going to do green. Let's make them a little bit different. And then always remember, you have to do that time.sleep. Otherwise, it's just going to blink and then turn off. Okay, so let's take a look, and we'll press save. And so we have 1, 2, and then all of them turn on. Victory! So that is how you use fill. You can use off in there as well. But if you want to do more than just the colors that I've given you, and this applies for both the cpx.pixels pixel number, or for the cpx.pixels.fill, then you can look at... You can look up for something called color picker. So if you just Google color picker, it's going to give you something like this. And you can find any color that you want. Let's say I want like a, I don't know, an oceany blue. Okay, so I think that color looks bright and nice. So I go to this RGB value down here, and those are the RGB values that I can use. So I'm going to copy those. And you can either make it into a new variable like I've done here, or if it's like a one-time thing, you can just put it straight in instead of the color name. So now, oops, sorry, let's go back a step. Okay, so you can put it in here where I have these variables, or you can put it down here directly into either the fill or the pixel color name. So I'm going to replace this green with those numbers from the RGB values. Now if I go back to my board and I press save, I should see 1 light, too light, all the lights. Oh, and oh yes, this is what I messed up on. Okay, so here's a great example of me making a mistake. So it says function takes 2 positional arguments, but 4 were given, line 46. Right, so this is line 46. What I forgot to do, I forgot to put a double parentheses. You'll notice all of these have a set of parentheses around them already. So let's go back and try that again. 1 light, 2 light, all the lights. Alright, so yeah, hopefully that's enough to at least get you started with this board. See you on the next lesson.